I was called out here to the corporate headquarters at Honeywell in Morristown. They had a building here, the Learning Center, that was experiencing multiple leaks and ongoing leaks.
We had a major rainstorm and wind got into the roofing system. Our system is composed of a mechanically attached insulation with a fully adhered membrane, and that wind caused the fully adhered membrane to tear from the insulation, and it created a circus tent almost, about 4 feet high, and ever since then we've had some problems with major leaking.
They asked me to come out and take a look at the roof, evaluate the roof for them, find out what the problems were and what are the best solutions for those problems. One of the things that I found when I went up there to do my assessment was there was some debris laying on the roof, such as a fastener that a HVAC person may have left on the roof without picking it up, and that type of debris. When you have that debris on the roof and somebody comes along and steps on a fastener, let's say, that fastener can very well puncture that membrane. Once you puncture or ruptured that membrane, you now have a hole in the membrane that allows water to enter the building. The roof that they had up there was not really the right type of system for this facility. They got a lot of rooftop equipment up there. It brings in a lot of foot traffic. So you need to design a roof that's going to be able to withstand the abuse that that roof is going to get. I was determined that we definitely need to replace that roof because it wouldn't have been a good thing to try to keep repairing it, spending money that I knew wasn't going to solve the problem.
We chose spray foam for 3 major reasons. It was the ease of installation, it was a very competitive cost, and we knew that we would generate an energy efficiency. And there was a 4th reason why we decided to go with it. It was the monolithic installation. The installation minimized the amount of seams on the roof, and since we have a lot of equipment on this building, we decided that that would be the best way to approach and mitigate any flashing issues in the future.
The scope of work on this particular project was to remove the existing EPDM membrane. The reason we wanted to do that is so that we could visually examine the existing insulation board and determine if there was any wet areas of that insulation. If we found wet areas, then we removed them and we put new insulation down so that we had a completely dry substrate. Once we had that, we came in with a secure rock board that was placed over the insulation, and that was mechanically fastened in place to the existing concrete deck to meet FM global requirements for wind uplift. Then we came in with the polyurethane foam system. This sample right here, if you look at the bottom board, that could represent the secure rock that was put over the insulation. Once we have that down, then the polyurethane foam is spray applied in place at whatever thickness that we specify on the job. And we also can taper that insulation to remove any areas of standing water. But once the foam is complete, then we come in with a top coat, okay? And that can be a number of different types of coating depending on what I want to get out of the system. But one of the main reasons for it is to protect the foam from things like the UV of the sun. Part of my job in this process is to not only write the specifications and design the new roofing system, but it's also to watch the installation of the job, make sure that it's going down according to the specifications that were written for the job, and also to check things such as the thickness of the foam. Was it put down in the proper thickness that meets the specifications? The coating, for example, is the millage correct on it to make sure that it meets the warranty requirements? I designed a new flashing system that's totally monolithic. It has no laps, it has no seams in it like conventional systems. Once that's done, there's virtually little probability of water ever entering the system because the whole flashing system is monolithic, again, with no laps or seams or anything to fail down the road.
The roof's been performing well. We had a recent rainstorm and we didn't have any leaks in the areas that we used to have leaks in, so we've been very pleased with it so far.